Everything that we're doing today in this level of training, Fighting Rifle 1, Introduction to Fighting Rifle, is you can consider to be in point blank range. So what is point blank range? Point blank range, if we look at Soviet doctrine, is better described as the straight shot distance. Straight shot distance, which, for example, all Kalashnikovs are actually calibrated with something right here called P. And sometimes the P is written in Latin letters, if this is from a country that uses Latin alphabet, or if it's from the Eastern Slavic countries, it's written in the Cyrillic P, which Americans will see it as pi, like what we do in math class, pi. P, it starts for prami, which is straight, okay, or straightforward, right? So the straight shot distance is your point blank range. Point blank range, in fact, means nothing, but that's the problem because it has taken on a meaning in popular culture. And so what you might call it in American slang, point blank range, is like really, really close, like right here, me to you. But that's actually wrong. The definition of point blank range is the distances at which you can assume your bullet flies like a laser. Just to be clear, do bullets ever fly like lasers? When we say ballistics, the science of bullets, it means the science of balls. Small balls, to be exact. There you go. Study of small balls. All right, we got a big ass projectile just for demonstration's sake, just because it's easy for you to see. And this thing is going to fly through the air and spiral to the right as it flies through the air. Is it ever going to fly like a laser? Flying like a laser meaning it arrives instantaneously. It's not affected by gravity, and it has no mass. Does this have mass? Mm-hmm. Yes. Is it affected by gravity? Yes. And does it arrive instantaneously?
No.
No. It takes time for it to arrive. And therefore, it's affected by friction. It has a size. It has a mass, has a shape. It's affected by friction. So bullets, or small balls, and the science of small balls, ballistics, external ballistics. When we study bullets flying through air, they're always affected by two forces. Number one is wind resistance, air resistance, friction. It's basically flying through the air, and it's rubbing against all that air particles. It's swimming through the air. And when it does that, it's losing energy. It's converting energy into heat. And therefore, it slows down. And it never continues flying at a constant velocity. It's always slowing down. And the next thing, it's always being affected by gravity. And gravity is not a linear force. Gravity accelerates it towards the ground at an acceleration of, 9.8 meters per second, causing it to fall faster and faster and faster towards the ground until eventually, theoretically, it would reach a terminal velocity. It's flying as fast as possible towards the ground. But bullets don't fly that long in the air, and I don't think they ever reach terminal velocity. I could be wrong, though. Maybe if you shoot it straight up, maybe it'll come down at terminal velocity. But generally speaking, on our way to the target, it's going to accelerate continuously, so it's falling at a faster rate always. Does that make sense? It's not only slowing down, spending more time in the air, but it's also falling faster. So the path the bullet takes in the air is never constant and is never instantaneous. Having said that, today's not a precision rifle class. Today's a fighting rifle class. And so at the level of knowledge that you need to have at the rifleman's level of knowledge, the average guy picking up a gun, being able to fight effectively, you're going to shoot it as if it was a laser weapon. You're going to shoot it as if the bullet will arrive instantaneously. You're going to shoot it as if there is no wind. And you're going to shoot it as if the bullet flies in a straight line, which it never does. This is called point blank range. Okay, so for our purposes, a modern 5.56 caliber weapon, something that chambers this thing. And let's zoom in here on these little itty bitty bullets. Can you? Mm-hmm. Look how tiny these things are. Look how small these bullets are. They fly extremely fast. By the way, these two, just so we have an explanation of these, this is a 5.56 M193, 55 grain lead core full metal jacket in the M16. This was the analog that was copied by the Soviet Union, which debuted in 1974, which today obviously is on the world center stage because both Ukraine and Russia uses this bullet right here called the Siemens-Schist, the 7N6, or Russia has a modified version of it, the modernized Siemens-Schist M. You basically have the same ballistic performance out of these two. They're wickedly fast, they're small, and when they hit an enemy, they turn around sideways and they flippity and they break apart. Okay. depending on what they hit and how fast they go, causing massive wounds. But I digress. The point is, these bullets fly really, really fast, and this allows them to have a very long point-blank range. Because if you have a slow bullet, such as the slow fat bullets out of the AK-47, or 8mm Kurz, or 30-30, or 300 Blackout, slow fat bullets, they're going to drop away really fast, and that basically means that we don't have as much point-blank range distance. Okay, so with an M16 or something similar, AK-74 or something similar, modern high-velocity 3,000 plus feet per second type rifles, we're looking at point-blank range of about 400 meters. That means within about 400 meters, we don't think about it, we don't worry about it, we don't compensate for wind, we don't compensate for time delay on moving targets. We just look, aim, point, shoot, and we hit it. Comments? Questions?